Hello, welcome. Okay, still on resistor combination. Before I continue with some other questions, okay. Now this is we're going to actually I'm going to correct something because it was just a slight. I would say it's just a slight mistake, but that mistake can actually make the answer to be wrong. Okay. Now it's about the current divider on ratio. Please, it's only on voltage divider, okay? Voltage divider ratio that is proportional, that we divide based on the proportion of the resistance. But in current divider, so please pardon me for this mistake, it's always the reciprocal, okay? The current across, remember, resistor actually opposes current, okay? So it is the resistor. A higher resistor will give you a lower current, and the lesser resistor will give you a higher current. That means resistor is inversely proportional. Resistance, please pardon me, is inversely proportional to the current. So in the case of dividing resistors on ratio, it's always the reciprocal of their ratio. So please take note. So I was getting the current. Okay, so this is where I made that heavy mistake, which I need to correct. So you have to also correct that. All right. So already we know that the current passing through the resistor. Well, let me still bring the circuit. Let me bring the circuit so that you know where I am. Okay, so here the circuit. Let me be the circuit. Let me bring it up here. Okay, so already know that the current passing through resistor R1 is 6 ohm, and that is 5 ampere. The resistor R1 is 6 ohm, okay, and the current passing through is 5 ampere. All right, so we've already gotten the resistance of X, okay, and we want to get the current passing. Now there are, okay, passing through the resistor X by I actually applied current divider, and I see it is always reciprocal. So what does that simply mean? Simply means that if I want to get the current I2, okay, passing through the resistor X, that is going to be equal to the resistor, okay, X, which I call it R2, okay. Now it's reciprocal. Remember, I would have used what I used previously was R2 divided by the total resistance, then multiply by the current, circuit current. But it is not how that is not how we divide current. Okay, this is how rather we divide current in reciprocal. That simply means that the total resistance now have to come up. This is always total resistance then divided by that resistance. Okay, the resistance you want to get the current, that's R2. All right, so let me do that. Divided R total divided by R2, then times the circuit current. So what I'm supposed to have now for I2 passing through R2 is going to be equal to total resistance. Remember, we've calculated that gave us, that was 15 ohms, right? Okay, divided by total resistance. What we had for total resistance. What we have for total resistance is 3 ohm. Please pardon me. What we had was 3 ohm. Remember, it was 3. So divided by R2, the resistance, okay, which of the resistance X we calculated R2 is 15. Then now multiply by the total current, the circuit current, which of course is 10 ampere. All right, so if I should do this, that's going to be 30 divided by 50. That's 2 ampere. If I still use that method to get R3, of course, if I want to get I3, the current passing through R3, okay? So you know how I'm still gonna the same principle. Total resistance then divided by the R3, then times the current. Okay, so let's flow with that. So let me put this aside. Okay, so how do we do that? So this is gonna be equal to total resistance R3 is 30 ohms. And of course times 10. Okay, so that's going to be 30 divided by 30. That's 1 ampere. Okay, so please just correct this the mistake we made on current divider, okay? But there is another simple way of actually getting this. What's just a simple way without going through the process of current divider. And actually, I missed that, okay? Of course, remember we've already gotten the voltage across 6 ohm resistor, and that is going to be the voltage across all the parallel connection, okay? We've gotten that voltage, that's V1, which was 5 times 6, that's 30 volts. So if we've gotten V1 to be equal to 30 volts, and you discover that V1, the voltage across 6 ohm resistor is going to be the same voltage across all the resistors in the parallel connection, okay? So there is no need of me going through a long process. So invariably now, it is just easy for me to get the current I2. Simple, okay? It's going to be the same voltage V1 divided by R2, which of course is, please pardon me, which is X. So that's going to be 30 divided by X, 15. We found that, okay, and that is 2 ampere. Okay, another method, but much easier method. I3, simple, 30 all over 30, and that is 1 ampere. All right, then I4, as simple as that, 30 all over 15, and that is 2 ampere. So you discover that if I should add everything now to show you that this is correct, remember, to show that this is correct, if I should add all this current, I1, I plus I2 plus I3 plus I4, they should sum to the total current. Of course, they should. So invariably, now if I should add it up, all right, I total is going to be equal to I1 is 5 ampere, I2 is 2 ampere, I3 is 1 ampere, then plus I4 is 2 ampere. So if I add 5 plus 2 plus 1 plus 2, that is 10 ampere, okay, which is the same as the supply current from the source, okay? So as simple as that. All right, so we can now proceed with more question. So we're going to look at series parallel connection. Now, sometimes you'll be given some complex connection that is a combination of series and parallel connection. Okay, so we're going to be looking at some example. Okay, here we go. So this is a question. Okay, let's do justice to that question. All right, here we go. This goes like this. In the circuit, find the current in all resistors. Also, calculate the supply voltage. Okay, so as you can see, I don't know the supply voltage, okay, but the current across the resistor, okay, from the supply current is 8 ampere, all right? So invariably now, and that current 8 ampere doesn't have not divided before it passes through 50 ohms. So that means the current across 50 ohm is the current of the circuit. So that means, let me call the current of the circuit to be I. Let the circuit current be I, okay? So that means the current across 15 ampere is I. The total, that's the current from the source. That's the current across 50 ohm, please pardon me, is the source current, all right? That is 8 ampere. Now, you know what happens as this 8 ampere actually flows and reaches this parallel connection, it actually branches, okay? Okay, let's say branches are entered into this I1, this is I2, and this is I3, right? Okay, and of course, you know it will divide in ratios of this 3 parallel connection. So now let's do that. First of all, let's get the total resistance of the parallel connection. Okay, so just the parallel connection, because I want to divide this current across this parallel connection. This one I've already gotten this current. Okay, just I'm dividing the current 8 amp across this parallel connection, so I need to get their total. All right, that's going to be 1 all over R1, which is 1 all over 10 plus 1 all over 5, then plus 1 all over 2. So of course, going by LCM, that's going to be 10. 10 divided by 10 is 1. 1 times 1 is 1. 10 divided by 5 is 2. 2 times 1 is 2. 10 divided by 2 is 5. 5 times 1 is 5. Okay, if I'm not mistaken. Yeah, I'm not. So if I should add up this should be 8 all over 10. Okay, so that means RT now is going to be equal to 10 divided by 8. I have to invert. Don't forget that I have to invert ohms. Okay, so let me divide that. If it gives me a long decimal place, I will use it as a fraction, since I still need to calculate. I've not gotten to the end of my calculation, right? Let's see what it gives. 10 divided by 8, 1.25. All right, okay, so that's 1.25 ohm. As you notice, the total resistance of the parallel connection is always less than, okay? So that means when resistors are connected in parallel, their total resistance will reduce, will even be less than the lowest resistance. So one way to actually reduce resistance, okay, is to actually connect them in parallel. Okay, so please take note of that. So after evaluating the total resistance of this parallel connection, it now reduces to 1.25 ohm. So please take note of that. That's one of the characteristics of parallel connection. All right, so now let's divide our current. So for me to divide our current, remember the division is based on reciprocal. So let me start with I1. So I1, of course, you don't have what is going to be. Okay, so that's going to be total resistance ROT divided by R1 times, okay, the current of the circuit. So of course, total resistance is 1.25 divided by R1, which is 10, times the current of the circuit, that's 8. Let's do that. Times 8, then divided by 10, that's 1 ampere. Okay, let's go for I2. I2, the same goes with I2, that's gonna be 1.25 all over 10, then times 1.25 all over 5. RT is 5, please pardon me. All over 5. RT is 5, right? Times the total current, 8. Here we go. 1.25 times 8. Then divided by 5, that's 2 ampere. Then I3, 1.25 divided by 2 times 10 ampere. Okay, so I'm having 10 divided by 2, that's 5. 5 times 1.25. That's 6.25, right? Okay, is that 6.2? All right, let's do that again. 1.25 divided by 2, then times, that's 10. Okay, so that's 6.25. Okay. Okay, so that's it, and that is our answer. All right, so let's actually now proceed. The next question is for us to find, okay, the calculate the supply voltage. So for me to get the supply voltage, that would be very easy. I will simply apply Ohm's law, okay? The supply voltage, total voltage is going to be equal to the supply current multiplied by the total resistance. So the supply current is 8 multiplied by the total resistance, which we calculated as 1.25. Okay, so that's going to be 8 times 1.25. What do we have? So the supply voltage is 2 volts. So as simple as that. All right. So we'll get more questions. Let me solve one more question. Is there a question? Okay. Okay, so I have something here which somehow looks complex. Okay, here we go. Find the equivalent resistance between the terminal A and B. So you see, this is a complex connection, right? Complex connection. And how do we resolve this resistor? Of course, it's a combination of series and parallel connection. So how do we get to know the series connection? I told you that if you want to know the series connection, trace through the path of current. If there's no branch, okay, then that particular resistors in that path of current are in series. For example, this is 3 ohms. If I should start from here, from this 3 ohm, go all the way to the 6 ohm. There's no branch, okay? The fact that the wire curved doesn't mean there's a branch. The only place where you have branch is this where we have branch. This is a branch. This is a branch because it divides, okay? But there's no branch. So that means 6 ohm and 3 ohm and 6 ohm are in series. The same happen here. There's no branch here. This 3 ohm and 3 ohm, they are in series, okay? So now everything now, this series connection is in parallel with this 6 ohm. This 6 ohm now, okay, if I resolve this, and this also is in parallel, okay? So let's start with resolving it one after the other. Let's start with this 3 plus 3, that is 6 ohm. So I'm going to resolve that. I use a single resistor, okay? Please pardon me. So I use a single resistor to resolve that. So this is going to be this 6 ohm. And that 6 ohm now is connected in parallel with another 6 ohm. Let me use this, okay? This symbol for resistor. It is much easier with this 6 ohm. All right. So now, this 6 ohm now is connected. This is how it's connected. Okay. Connected again. Then now, this is the last series connection, 6 plus 3, which is 9, okay? Connected with 9 ohm resistor. So as you can see, I can resolve this and this. This and this are parallel. This and this are parallel, okay? So let's resolve the two, all right? So let's use our shortcut to resolve these two, okay? The total, let me call that R1, okay? I can use anything. That's going to be equal to 6 times 6, product all over sum, okay? Divided by 6 plus 6. 6 times 6 is 36, then divided by 12. 36 divided by 12. That gives me 18. That means the whole of this. I've resolved this. The whole of that is 18. So I can redraw that. I can still redraw that, okay? This two 6 ohm are parallel. If I resolve it, it gives me 80 ohms. Okay. I'm mistaken though. Please pardon me. 36 divided by 12. That's not 18. That's 3 ohms. Because it should be less than the lowest resistor in that parallel connection. So that's 3 ohms. Okay, so this time I'll do the same to this. Of course, this is 6 ohm here, right? Let me resolve this. Their total, let me call that R2. That's 6 times 9 divided by 6 plus 9. Okay, of course, 6 times 9, what is it? That's 54. 54 divided by 6 plus 9. Okay, so 3.6. So the whole of this connection here is 3.6. So let's go again and connect. So I have another resistor here, right? Okay. This, don't forget that this one here is 3 ohms. This one here is 6 ohm. All right. This is also 3 ohms. I've already resolved the whole of this, the whole of that resistor here, which of course gave me 3.6 ohm. Okay, so as you can see now, with what I have, this resolution, as I keep on resolving, I will redraw. Okay, as you resolve, redraw so that you have a new connection. From this, you can now see that this is another series connection. The 3 ohm and the 3.6 ohm is in series, and this 3 ohm, okay, this 3 ohm and 3 ohm are in series. Okay, so I can still resolve it again. If I resolve it again, I'm gonna have 3 plus 3, that's 6 ohm. All right. The same thing happen here. 3 plus, okay, 3 plus 3.6, that's 6.6. So of course there's a branch here, which is 6 ohm. Okay, everything now is in parallel. 3.6 ohm. So everything now is in parallel. So I'm gonna have 1 all over RT. Now is gonna be equal to 1 all over 6 plus 1 all over 6 plus 1 all over 3.6, right? So the LCM is 6 times 3.6. So that's 21.6. So 21.6 divided by 6, I have 3.6 here, plus 3.6, then of course plus 6. So let's add that up. 3.6 plus 3.6 plus 6. That's 13.2. 13.2 all over 21.6. So I have to now reverse. Reversing it, I'm going to have 21.6 divided by 13.2. All right, so let's do that. 21.6 divided by 13.2. Okay, so approximately 1.6 ampere, 1.6 ohm. Okay, so that is how you resolve that. That's how you resolve that. All right, so that is it for now. We're going to be looking at more in the next video. All right, see you in the next video. Thank you very much.